Describing algebraic expressions. List the variables and the constants for each algebraic expression. Looking at example A, I've got R, which is a variable, showing up twice here. And then I've also got H, which is a variable. What's interesting about this problem is pi, the symbol pi that's sitting here. And a lot of times students think that that's a variable because it's a Greek letter, and often we say that variables are listed as letters. But pi is actually in the place of a number, so we consider it to be a constant. So in this example, the variables are going to be r and h, and the constants are going to be 2 and pi. In example B, the variables are capital L and W, and the constant is 2. In example C, we only have one variable, it's y. It shows up twice, once in each of those terms. And the variable here, the constant here is 4. Example 7. Evaluating an algebraic expression at different values. When we have an expression, such as this one here, 11 minus 3y, we might want to know what its value is at different numbers that we exchange for the variable. For example A, we're going to take the number 2 and we'll substitute that in anywhere that we see y in the original expression. So 11 minus 3, and we'll put a 2 instead of the y. 11 minus 6 is 5. For example B, we'll have 11 minus 3. We'll substitute 0 in for y, which is 11 minus 0, or just 11. For example C, do that over here, I have 11 minus 3 times 2/3. It might be helpful for us to write this 3 as 3 of 1 so we can think about multiplying those fractions together. So this will be 11 minus, those 3's are going to cancel here. 11 minus 2, which is 9. And then for the last example D, 11 minus 3, we'll substitute a negative 5 in for y this time. I've got a negative 3 multiplied by a negative 5 here. So that's going to change into plus 15. So this will be 26 overall. For example 8, we're doing the same thing that we just did in example 7, but it looks like our expressions are a little more complicated. And for letter A, we actually have y showing up in two places, once in the numerator, once in the denominator. So we're going to substitute that 5 for y in two locations. So I'll put 5 plus 3 in the numerator, and then 5 minus 3 in the denominator. This is going to be 5 plus 3 is 8 over 5 minus 3 is 2, and then 8 divided by 2 is going to be 4 overall. For letter B, we have 7 minus 2 times a negative 2. Negative 2 times negative 2 is positive 4. So this is going to be 7 plus 4. So my overall answer here is 11. For letter C, let's see, we'll have 1/3. Pi is just a number. And then we're taking 11 and we're plugging that in for r, so we're going to take 11 and square it. So let's see, 1/3 pi, 11 squared is going to be 121. I don't think 121 is evenly divisible by 3, so this will be 121 times pi over 3. Because pi and 121 are both just single numbers, they belong in the numerator of the expression there. For example D, I've got two variables. I've got p and I've got q, so I'm going to plug them in separately. So p is a -2. We're going to square that. And then q is 3. And then that whole thing is being cubed. -2 squared, -2 times -2 is +4. 4 times 3 gives me 12. And then 12 to the third power, I've got to do that in a calculator. 1728. For example E, similar to the last problem, I have two different variables to look at, m and n. So let's see, we'll have 4. M is equal to 2/3, and n is equal to 1/3. And then I've got them switched, 1/3 minus 2/3. Okay. 2/3 minus 1/3 will be 1/3 overall. But then in the other parentheses, I have 1/3 minus 2/3. That's a minus 1/3. 4 times a third is 4/3. And then I've got a negative times a negative, which is a positive. So this will be plus 5/3. 4/3 plus 5/3 is 9/3. And overall, that's just 3.